welcome to CAS Tutorials, and in this video I'll be covering practice problem 7.8. If you haven't subscribed to the channel, please subscribe, and if you like this video, just go ahead and hit the thumbs up button. So let's get straight into the question. We're given this piecewise function over here, and we are asked to express it in terms of singularity functions. So this is what you do when you have a piecewise function. So the first thing you have to do is you identify the limits or the inequality which you have in front of you. So the first part of it says 0. And if you look at this, this is for time less than 0, which is equivalent to something like that, right? You move on to the next value of the function, which is -4. Then you look at the inequality. The inequality starts at that point, which corresponds to a unit step. And you then subtract the other unit or the other value which forms the extreme of the inequality, and therefore you subtract the other part, which is like that, and this is for time equals to 2. So you basically take the lower limit and you put it there, and you subtract the upper limit to form your bracket, and then you multiply your bracket by the value of the function at that particular inequality or in that interval. So this is what I'm going to do to continue from here. So this is 0, that is -4 with the limits, and I'm going to add 3t, which is the next one. 3t subtract 8 with the inequalities in play. So u of t subtract 2. This is the first limit or the lower limit. Subtract the upper limit of 6. Then finally, I'm going to have, this is for time greater than 6. Finally, I'm going to have 0 multiplied with whatever, which here is for time greater than 6, going onwards. So until infinity or whatever. So these two can be omitted because they are basically just 0. And we have h of t is equals to -4 multiplied by u of t subtract u of t subtract 2 plus 3t subtract 8 multiplied with u of t subtract 2 minus u of t subtract 6. So just a few things to note, or just a reminder, just so you have fun and you don't really struggle when you're going through problems like this. So let's put it on this side, nota bene, or and b. So if you have t, u of t, it is equivalent to the ramp function, which is r of t. And if you have a delay here, so let's say a delay of t subtract 1 with a function which starts at, which is delayed by 1, which looks like that. This is the equivalent of the one at the top, just that we now have a delay, and therefore you now have r of t subtract 1. So this is going to come in handy, and we're going to use this to actually solve this particular problem. So now here's another tip. If you see the variable t being multiplied by any value, you can basically split this up to the number of the constant which you have over here, and I'll show you just now. So let's deal with this bracket over here before we deal with anything else. So I'm going to start with this part. So taking this part down here, we're going to split this into 3 parts which actually correspond with each of these. So let's do that. So multiplying through, we're going to have 3t. This is only this part. I'm going to look at the top part in a bit. So let's do that quickly. So 3t subtract 8 multiplied by u of t is going to be, I'm going to have u of t subtract 2. Then we're going to have -3t minus 8 multiplied by u of t subtract 6. So that is that. And as I said, we look at the number of times or the number of constants which are actually multiplied by the variable t. So we're going to break this up into 3 terms which correspond with the time delay which is in the unit step function. So this is what's going to happen when I say t subtract 2. So 3 times we're going to have something which is similar to what's inside the bracket. So that is what you have to do. For the number, I'll say it again. For the number which is multiplied by t, just form these expressions which match the expression which you have inside your delay. So t minus 2, we're going to have 3 t minus 2's because we have 3 multiplied by t. So we're going to add t minus 2, then we're going to add another t minus 2. But now we have to be in keeping with this constant which we have over here. So what do we have? We have minus 2, minus 2, minus 2, which is minus 6, but this is minus 8. So we're going to add a minus 2 over there to make sure it's the same value. And we're still going to multiply by u of t subtract 2. So this is for this part, right? This is for the first part. Now taking this part over here, which we have over here, we're going to do the same thing. We're going to split this into 3 because we also have 3t. So we're going to have 3. But now our delay is of 6 seconds. And therefore, we're going to say t minus 6 3 times. T minus 6 plus t minus 6. So that is t minus 6 3 times. And we're going to have negative 6, negative 12, negative 18. But the value which you have here is actually 8. So we are going to add 10 to make sure we're in keeping with this negative 8. Then we're going to ultimately multiply by u of t subtract 6. And not forgetting the negative sign which precedes everything. Therefore, we're going to have a negative multiplying everything. So now, it's now time to simplify all of these things. Looking back at what I just said here, t of u of t is equal to r of t, and t minus 1 of u of t minus 1 is equal to r of t minus 1, right? So we now have 3 of these t minus 2's, which is similar to this case. So we have 3 of those, which means our result will be 3r of t minus 2, because we have 3 of those. So essentially we have 3t minus 2 u t minus 2, right? Which is going to result, because of this, which is going to result in 3r of t minus 2. But we also have this minus 2, and therefore we're going to factor that in, and we're going to have it over there. Right, so this is just a simplification of this first part, this part over here, right? And now we're going to simplify this second part, which we have down here. It's going to be a similar story, so not forgetting the negative which precedes everything, 3r of t minus 6, because we have 3 t minus 6's. And finally, we also have this 10. Let's not forget that. So it's going to be multiplied by negative as well, so it's going to be negative 10. Right, it's going to be negative 10 just like that, and we are going to say negative 10 u of t subtract 6. So that is the value which we have over there, right? So this is the simplification of the second part. This is the simplification of the first part. So we're now going to proceed and combine everything that we have. So let's go back to the original, or the first expansion which we did. So now our final answer is going to look something like this. H of t is equals to, so multiplying this negative 4 with this unit step. So negative 4 u of t. Then we're also going to multiply this negative 4 by that. So it's going to be plus 4 u of t minus 2. Then over here, we simplified this part and this part multiplied by that. And the simplification was that. The first simplification, so we're going to add 3r of t minus 2 and negative 2 ut minus 2. Then finally, you're going to add the second simplification, which is over here. So we're going to have negative 3r of t minus 6, subtract 10 u of t minus 6. And now we just have to see if we have any common factors. We do have common factors. If you look at this, this is u of t minus 2, and this is u of t minus 2 as well. So 4 subtract 2 is 2. And therefore, our final answer is going to be negative 4 u of t plus 2 u of t minus 2 plus 3r of t minus 2 negative 3r of t minus 6 negative 10 u t minus 6. And this is our final answer after simplifying everything.